Okay, so today I want to show you how to make a simple setup for lasers. So you can have a laser, multiple of them. You can have mirrors with kind of infinite bounces, and you can create even crazy things like funky mirrors, or you can make even portals like this. Okay, so before jumping into Unity, let's just have a look at what we are trying to achieve. We want to have a laser with some mirrors and a laser beam that will bounce off of them. And there are two ways to do this. You can go for option A, where you only have one class, laser source, that will calculate the entire path of the beam. But it's, while it's easy to do, it's kind of not scalable. So let's actually do something more advanced. And it will be a little bit hard at the beginning, but at the end you will see why is it much better. So for option B, we will have three classes: laser, laser beam, and mirror. And the laser beam will be a smaller class, but you will have multiple instances of it. Okay, so we can jump into Unity, but before that, we don't have to copy paste everything because I've put everything into a repo, which will be linked in the description below. Okay, so this tutorial will be divided into three steps. In the first step, we are just going to make a simple laser beam with a line renderer that will just hit any obstacle, but mirrors will be not yet working. Okay, so we have basically two classes. We have a laser source class, which has a source transform. This is the origin of the laser beam, and then it has a laser beam. Laser beam is a class which needs line renderer, and this will be used to actually draw out the beam visually. It will have just two positions, the line renderer. It will have the starting and the end position. Okay, so the laser source class only has two references that I mentioned, and then in the update method it will just take the laser beam class and call a propagate method. This propagate method takes a starting position of the beam and direction in which it should propagate, and then the propagate method will do the rest. Okay, so this is the laser beam class, which has the propagate method here. Before going into that, it has a couple fields. It has a start position and a hit normal. So this will be set in case we hit any collider, then we will set the hit normal. Then it has the longest beam distance, so in case we are not hitting anything, it will have maximum of 100 meters. And we need the reference to the line renderer, which is required for this class. And in the evade method, we just get the line renderer reference and we set the position count to 2. So now we get to the propagate method, which again, it takes a start position and direction. Okay, and then it's using physics rekas to basically check if we hit something. In case we hit something, then we just take the hit point as the end position, and we take the hit.normal as the hit normal. In case we don't hit anything, then we are not setting this value and they will be just default. And here at the end, we just set those values for this class. And at the very end, we just update the visuals, so we set the start and end position. Okay, so this is the end result. As we can see, anything will block the laser beam, but the mirrors are not working just yet. Okay, so now in the second step, we will make the mirrors work, right? So now we can have mirrors, they can have any amount of reflections, and there are no bugs as far as I know. So what is new? We have a new class called mirror. The mirror is responsible for calculating the reflected beam. And how does it do it? It stores laser beam pairs. So for any incoming beam, we will create a new beam, which is called outgoing, and we will calculate the propagation on this beam. This propagation is done or defined in the propagate method. So for any laser beam that is incoming, we just want to calculate what is the direction that it will be reflected at. So that is very easy to do because there is a method for this, vector3.reflect. It takes the incoming direction of the beam and then the hit normal, which is already defined here. When we have the outgoing direction, then we just take the outgoing beam and we propagate it. So we now call on the laser beam itself, the propagate method again, and we set the starting position to the incoming beam end position, and the direction is the one that we calculated here. Okay, so short recap. what does this class do is for any incoming beam that is hitting this mirror, it will create a new beam, outgoing beam, and it will call propagate method on the laser beam itself. And because we store everything in a list of laser beam pairs, we can actually have any amount of laser beams hitting this mirror and it will still work. And to make this work, we have some changes in the laser beam class as well. Most importantly, in the propagate method, we are adding these lines. So whenever we hit something with the raycast, we want to check whether this collider has component of type mirror. If it does, then we want to store the reference to this mirror locally in this class. In case we did not hit any mirror, then we are setting this property to null. And likewise, if we did not hit anything with the raycast, we get here, and in this case we are also setting this reference to null. So this means we are not hitting any mirror. And here at the end is the last change. So in case we are hitting some mirrors, then we will call propagate method on the mirror itself. Okay, so if we go back to our sketch, this is how it works. The laser beam creates the first instance of laser beam, and it knows the starting point and the direction. This is given by the laser, and then it will create a cast, it will hit a mirror, and then it will register on this mirror that a laser beam hit. Then the mirror itself will take care of creating a new instance of laser beam and also of calculating where the new beam is hitting. And if it's hitting another mirror, then the thing repeats again. So again, this mirror registers this laser beam and creates an outgoing beam. So you see this recursive. So then if we have an infinite, not infinite, but a high number of reflections, everything will still be calculated. And there is one thing I didn't explain yet, and that is what is this register laser beam and unregister laser beam good for. And this is basically to let the mirror know that if there is a new laser beam hitting this mirror, then we want to store this in the laser beam pair list. And in case there is a new one, we want to add a new one to the list. In case an existing one is unregistered, we want to remove it from the pair. We want to destroy the game object, so the laser beam. And also we want to call on any mirror that is hit from the outgoing beam. We also want to call unregistered laser beam. Okay, so these two methods are actually used by the laser beam whenever we are setting this reference either to null or to something else. Then we are basically checking if we should unregister a laser beam or register a new one, or we sometimes have to do nothing if the reference is the same. Okay, so this mirror script now gives us a functional mirror that can handle many laser beams, many reflections, and everything seems to work. So far I haven't seen any bug in here, so you can guys play around with it. Okay, but that is not all, because now we are getting to the first stage, which is the more funky one. So now you can have your own fun with the system, because you can still have the mirrors working, right? This is still, everything is fine, everything is functional, but you can create your own stuff. So I made something called portal. So any beam coming to this portal will be going out of this portal, and you can even rotate this portal and it will still work. And you can even do some funky things as sending the beam from this portal back to where it belongs. So do the first portal and it still works. It's a bit funky, but it works. Okay, so what did I change? I added a new class called optical element, and it is an abstract class, okay? And it has basically the three methods that the mirror had that I showed you. They are now here in the optical element, and they're all abstract. So they are just a placeholder for any optical element that you want to have in your system. You will have to define how it should behave, or how the laser beam should behave. Okay, so if we check now, mirror is not just a mono behavior, but it is an actual optical element, and it has to override these methods and define the behavior of this optical element. And here I actually didn't change anything, so this is still the same. Then a second small change is on the laser beam class, we don't have the reference to the mirror that we are hitting anymore, because now it can be any optical element. So you see, this is the optical element that the beam hit, and also here in the propagate method we are trying to get any component that implements the optical element. So the interface, but the abstract class. Okay, so now you can add any optical element to the system, and if you just implement these methods so that they make some sense, then you will have a new optical element working with the previous optical elements, and they can be combined in any manner. Okay, so here I made, like, just for fun, a simple portal, which is actually very similar to the mirror. Actually, these two methods are the same, the register and unregister, so we don't have to even look at it. The only changes here is how we calculate the propagate method. And the difference is that we actually created the beam at a different spot. So we created at the target position, which now corresponds to the other portal. And we also compute the direction a little bit differently. I don't actually want to go deep into this because it's not so important. But the point is, you can do anything you want here. You can create real elements, optical elements, or they can be sci-fi, fantasy, optical elements that make no sense in the real world. This is our game, so we can do funky stuff like this. Okay, so this is the end game. This is where we end. We have the portals working, and don't forget, we can also use a second laser. Everything will still be working. You can shoot it at the portals as well. They can handle any amount of lasers. And yeah, that's it. So you can find the source code, it's linked in the description. You can play around with it, you can make new stuff, and please, if you like the tutorial or you want to give some feedback, subscribe and give me the feedback. This is my first video, so it won't be the best yet. Thank you for watching and see you later.